Good morning, good afternoon, and good evening, and welcome to Umlink Energy Speaks Back, powered by Hark. My name is Paul Webb. I'm the founder of B2B Energy, and I'm your host. And weekly, I present to you experts from around the world. Welcome to episode 79. And my special guest today always has the environment at the top of her priorities. She has a driven passion to use her knowledge, skills, contacts, energy, and time to deliver powerful, practical solutions for individuals and organizations which fully support and advance the sustainable agenda in all its forms. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. On our journey of knowledge sharing, we would like to thank our sponsors, and they are SmartCall for their AC initiatives, Umlink, who are taking the confusion out of energy management, Park Systems, renowned for their energy software, Clean Energy Revolution for their knowledge and networking through LinkedIn, B2B Energy for their 11-week energy program training, Alexis Energy for power management, led by Vision for their LED and controls, Watts for their electronics and EV transition, Carbon Black Global for their waste to energy initiatives, Cinefex for their insulation and coating, and lastly, our certificate partners, Esther Energy. So without any further ado, I give you Samantha Mant. Good afternoon, Samantha. How are you today?
Good afternoon, Paul. I'm extremely well, thank you.
Good. And I always like to comment on the back of people's screens. It looks quite sunny where you are. Whereabouts are you in the UK?
We're in Bristol.
Bristol.
I wouldn't say sunny, but I'm making the best of the light, clearly, here, what's left of the afternoon.
But we've had a beautiful day today in the UK. It's been like the spring has come, isn't it? It's quite nice.
Such a relief after the last few weeks, yes.
Yeah.
But much more fun walking the dogs this morning with the sunshine.
Yes. So we have met once in person on an exhibition, and that was quite exciting because, it's funny, we're saying exciting nowadays because mostly everyone meets through Zoom, don't they, and online. But we had a face-to-face and we got chatting about your technology, which we're going to hear more about. But for the benefit of our listeners today, could you give some background into yourself, where you've come from and your origin story?
Yeah, sure. So my background, I've gone through sort of 3 or 4 industries in the time. I'm a slightly more mature lady. But throughout all of my jobs, which are varied, I sort of started the market research industry for a few years, and then I morphed into a major donor fundraiser for about 15 years and came up through some large regional and national charities. And then I morphed into a small business owner. And then I morphed into another small business owner with a different business. But curiously, the thread, not deliberately, interestingly, but the thread through all of those, or most of them, has been water. And right. Even when I was a charity fundraiser, my interests and my passions and my commitments around environment and conservation, and I did my degree at UCL in geography. And then I tacked a bit of law on later, but that was sort of a bit of incidental. But geography was my thing, and then I came up, and a lot of my volunteering was around environmental conservation charities, WWF, that sort of thing. So when I ended up in the charity sector, I very much focused on environmental charities, educational charities, that sort of area. So I was working for WWT, the Wildfowl and Wetland Trust, and I was the fundraiser for their London Centre, the Wetland Centre, which is my baby. And then I moved on to Atlantic College, which does a lot of environmental stuff and part of its social programme. And then I went to Bristol Zoo and was heading up the team to build the new zoo, which was going to be an international environmental centre. and then sort of came curiously off left field with my, as you do in life, and came curiously off left field to start a small business with my now husband, which was a bathroom fitting and plumbing business. And that was a steep learning curve. And we did that, we ran that together for about 12 years. Wow. And, but towards the end of that, we came across Halcyon. And it became very apparent to me very quickly that Halcyon actually sort of brought an awful lot of the threads of my life and my interests together. So I think that's quite good timing, you know, being a little bit older. And as soon as I heard the statistic to do with Halcyon and carbon and energy, I kind of went, this is not just a bit of nice treatment for limescale to keep our bathrooms nice. This is what I'm designed to do. This is what it all could have brought together. All those threads have come together. So we ended up closing the main business, and I just after I opened up Halcyon Limited as a business of its own, to focus all my time in a sense on this bit of kit, because it brings together so much of my history, and I think for me it's very much a case of this being my, I don't like the word legacy, that's not what it is, but this is how I do my contribution. I do it through water, but it's about the environment, it's about conservation and so on. So that's sort of how I've come here.
I like the way you used the word morphing, because that I had a complete picture of you morphing from one to the other into that and migrating into these different industries. And I'm really pleased that you're talking about water, because when I talk about energy management, I talk about gas, electric, and water, because I think water is very precious. And we do take it for granted regarding water and what we're doing with that. But it has contribution to the gas and electricity. But at the same time, it is precious, you know?
Absolutely. So there's so many pieces to that. Two or three key pieces. I mean, water we treat certainly in this country as if it's, you know, infinite and utterly abundant. And the statistic is that, and I might get this slightly wrong, but it's something like 0.01% of fresh water on the planet, of water on the planet is fresh water available to us as humans. So 0.0, it might be 1 or it might be 4%, but either way, it's a fraction of the water we see that is actually available to us as fresh water. And so, you know, in this country we have lots of rain and we feel plentiful and all the rest, but when you look at, if you ever had a chance to look at a stress map of the UK even for water, there are some serious water stresses going on about where we will be running out of water, where we have to do different things to secure our water sources. So we take it for granted, and I think a lot of Western societies do take it for granted because you just expect water to come through your taps. We are very complacent about the quality that we get, which is exceptionally high, and we're complacent the fact that it will just appear, and we don't think about how it got there, the enormous process to get us this extraordinary and you know, fundamentally essential resource. It's more essential than power, fundamentally. We can live without power. We can rub sticks together and make heat and do other things, but you know, we can't do without water. And so you've got this incredibly scarce resource. And then we layer on top of our general attitude of turn the tap on, lots of lovely clean water, don't worry about it, you know, leave it running while you're brushing your teeth, don't worry about how long the shower is, all the things that we hear coming through now as water conservation measures, which are all critical and small measures to take, but we take it for granted. And then we've double layered that by then not charging for it in any significant way. So water is the cheapest utility we can buy, and yet it's our most essential. And you just go, how do we get to this place? You know, and then we can, you know, we complain about it a lot as well. But actually, water is incredibly important. And then you take it, and that goes, okay, so that's water, and it costs, you know, we use a lot of energy to move water around the system to get it from the hills of Wales, for us, for instance, to get it from the hills of Wales down into Gloucester or Bristol. It's not all gravity. There's a lot of pumping goes on. There's a lot of other things. There's a lot of treatment, and all of that is consuming energy. And we don't really give that much attention. It's quite comforting to see that the water energies are now actually really focusing in on how they can reduce their energy consumption to move water around and treat it.
Yeah.
And that's without even starting on hot water. And hot water sort of seems to be the poor relation of heating when we're talking about, yours and my conversations around serious energy consumption. When you're looking at that, I mean, in the domestic dwelling, we know that heating space consumes by far the majority of the energy. Okay, get that. So there's a really good reason why the retrofit and the build are focused on insulation and air tightness and all of those things, and original build. There's a really good reason for that, because it is the majority of the energy. But the second largest consumer of energy in a domestic dwelling is hot water production, 14%. I think it's more. The EU is 14. I think the UK figure 16% of our energy consumption at home is on hot water. And we're not really talking about that. We don't, we talk a little bit about boiler efficiency, but that tends to be associated with heating, not hot water. And so you've got this lack of recognition that actually heating, and again, water has one of the highest specific heat capacities of anything, of any material, more than aluminium, more than lead, more than iron, you name it. I've got a lovely, pretty little graph that runs up, and the little pretty graph shows all the metals and other materials, and then this whacking great column that is the specific heat capacity of water. So we know that water takes a huge amount of energy to raise its temperature. And yet, again, we just treat it really casually. We don't talk about it. So you've now got this resource that we use in huge amounts. We actually use quite a lot of hot water in this country. And we don't talk about how much energy it takes for us to then create that hot water. And I think the global figure is that hot water is the largest consumer, hot water production is the largest consumer of electricity globally, full stop.
Yeah.
So from an electricity generation point of view, it's the biggest consumer. And then, of course, you get into our little bit of the world and our little niche, which says, well, okay, this hot water production thing, it's really expensive on energy. And then you go to a hard water area, which is the majority of areas, and you go, so let's take that really expensive process and make it much, much worse. Because now we're going to bring hard water into the equation, which is wonderfully healthy for you, brilliant, loads of lovely minerals in there, consume away merrily. But one of those minerals, calcium carbonate, anyone in a hard water area knows and will tell you will create that white, crusty limescale. Well, most people think about that being a bit of an eyesore, nasty to have to clean, don't like using the chemicals, blocks up the shower head, all of those things, all of which is true. But what people don't realize is that limescale, that hard, white, crusty stuff, is in a phenomenally good insulator. Shame we can't find a use for it, frankly, because it's a really good insulator.
Yeah.
But when you put an insulator around your heating element, you then have to use lots more energy to heat the water when you want it up to temperature. So now your heating element has to be on far longer and work far harder to heat up the water to the temperature you want. Because this is the statistic that got me into this business. This is the thing that is my raison d'etre, is that every 1 millimeter of limescale on any heating element, domestic, commercial, doesn't matter, adds 7 to 10% to its energy consumption.
Wow.
And there is nowhere that has 1 millimeter, because the whole nature of limescale is to bond to itself. It bonds to the surface, then it bonds to itself, and which is why we see these great big crusty layers.
And it builds and builds and builds, does it?
Absolutely. The whole nature of what in its original form was called calcite. The whole nature of that is to bond to itself and to surfaces. So it likes a bit of temperature. Over about 40 degrees, it starts to precipitate out. It starts to bond to the elements more quickly.
Yeah.
And then it'll bond again to itself and again to that. And of course, on the hot water side of your boiler, your system, every time you turn that tap on, you're drawing lovely new fresh water into the system from the mains with its next dose of minerals, with another load of calcium carbonate coming through into the system that can then go, oh, great, and bond onto your heating element, onto your fixtures and fittings. But around the heating element, it's just not being talked about. We're just not talking about the fact that 60% of the UK has hard water, and that's 60% of our businesses, of our homes, all of which, bar the 1% that actually treats their water, are wasting, well, let's say conservatively, they've got 3 millimetres. 21% of that energy, of the 14%, every time they turn on and ask for hot water. And it's just crazy. It's crazy that it's not part of our dialogue.
Can we drill down to those areas? You mentioned 60% of the UK has this problem. Yeah. Is it in specific areas, and why is it in specific areas and not in other areas?
Yeah, okay. The why is the how do you get hard water, and that's where, you know, your rainfall is your source of water. Rainfall's on the ground as it's percolating through certain types of rock, limestone in particular. It picks up as it goes through. It sort of gradually erodes and it picks up the minerals on its way through until it ends up resting in the aquifer or ends up going back into the rivers or whatever. But as it's dissipated through the rocks, that's where it's picking up the minerals. And we have that kind of rock in 60% of the UK. So geographically, you're looking at, when I look at a map, sorry, I'm drawing a map in my hands here, in my head.
Yeah.
You can exclude Cornwall and a bit of, you can exclude South Wales. They've all got super soft water, no hard water there. You can exclude the northwest, so sort of Liverpool, Manchester up through the northwest, and you can exclude most of Scotland.
Right.
But northeast, Midlands, M4 corridor, south coast, southeast, London, all of London, and the East Anglia, hard water. And obviously that varies. You know, if you're in Essex, Norfolk, Wiltshire, Plymouth, not Plymouth, Portsmouth, you know you've got hard water. You know, one gentleman in Wiltshire had a lovely phrase he used when I met him at a show, and he said, "Oh, hard water." He said, "Yeah, we shower in hard hats around here," and I thought that was a really lovely way of.
Samantha, do you know that I'm an Essex boy?
Oh well, yes, we.
That's why I've got the dents on the head. Then is it?
Yeah, exactly.
And I haven't got no hair.
Yeah.
It's because the water's just too hard for my head.
Too hard. It's just eroded away at your hair, yes.
Yeah.
But I mean, Essex is one of the key areas we sell into, because they have really hard water and really hard limescale. And there's a huge amount we don't understand about limescale. The whole industry just doesn't really properly understand it. Yeah. But we understand just about enough to treat it.
And then some of our listeners are from around the world. So have we got this problem globally?
Yes, absolutely. So you've got certain countries which obviously don't have their own sources of water. So they, you know, like the Middle East will desalinate and use desalinated water, but then they remineralize, and which is good because it's healthy. Yeah. But it's healthy water that they're getting back. But then of course they've also recreated the problem of the limestone. So that's one sort of set of countries where desalinated water is their source. But
they don't have a heating issue, do they? Obviously they have to heat hot water.
No. So areas like Australia, for instance, they won't have boilers. They'll just have an instantaneous hot water unit. But I know, for instance, that a few years back, Perth has now changed its water supply. But Perth used to have its water coming from an underground aquifer, huge underground aquifer, and it was hard as nails. And it's their housing association there had, I don't know, 3,000-4,000 homes that they looked after, and they were chucking away the instantaneous hot water units, sort of big jobs, every 18 months, 2 years. They literally just threw them away because they couldn't fix them, they couldn't replace them, so they just binned them. And that's crazy. I mean, again, going back to your point about energy, not only is during that period, those units have burnt huge amounts of unnecessary energy to provide the hot water, But you've now got this vast amount of embodied carbon in this instantaneous hot water unit that is being chucked away after 18 months, 2 years. What's that about, Sarojini? That's, what's that about? It doesn't make any sense. So we need to protect the equipment, partly to be more efficient, but partly to make sure it does its 10 years, that it lasts the duration, that we're not trashing equipment.
So now we've got an understanding of the problem, what's creating this problem.
Yeah.
Where do we now look to the solution to correct the problem? Can we correct the problem 100%, or do we just part correct it? Where are we with that?
Okay, that's a good question. So can we correct the problem? Yes. Simple answer, yes, we can. Does it have to be complicated? No, it doesn't. Traditionally, the main solution of choice for the last few decades, and it's only been recent decades that we've actually bothered about it, is been salt softeners. And I think most people are familiar with the concept of a water softener. And we've got stuck with the idea that hard water's bad, soft water's good, and therefore if we soften the water, all will be well. Now, there is some truth in that, but it misses the point that actually hard water is extremely healthy for you, extremely useful, and it's only got one little behaviour that makes it troublesome, and that is this mineral that bonds to things and creates limescale. The rest of it's absolutely fine. So salt softeners have quite an intense process. You've got, a big box and you feed it with salts and you maintain it. And what happens inside, and this is super simplistic, but that's how I work, is basically you feed it with salt and then they have a regeneration process, which means that salts get swapped out for the minerals are removed from the water and flushed away, and you then get water which has, it's a very, very mild brine. There's very little salt, but there's a mild brine in there, and that's what's supplied to the house. So a well-maintained salt softener, diligently looked after and fed regularly with enough salt, can do a good job of preventing limescale because there are no minerals in the water. But you need a separate drinking water source, or that's what British Water recommends because of this slight salinity in the water. You've got to give up a cupboard, and you've got to keep feeding the beast with salts and so on, and all the carbon footprint that comes with mining the salts and shipping them and storing them and getting them to your house. And of course, when it refreshes itself, it purges that water, and you've then got a brine solution going down into our waterways. Well, that's not really great either. Our waterways are struggling enough as it is. They don't really need any more sort of effluent heading down towards them if we can avoid it. Yep. So that's the traditional concept of treating water. But if you scale that up to an industrial sense, if you're a food manufacturing plant, you're dealing in vast amounts of salt. I mean, huge amount, hundreds of thousands of pounds of salt every year, with all the carbon footprint and all the hassle and so on and so forth. In more recent years, and this is only starting to get traction because ours is not an industry that moves quickly. Ours is definitely not a fast-moving industry. But in more recent years, what's been happening is a lot of the conditioners that I think quite rightly people were quite skeptical about. There's a lot of electrical wires and magnets and electromagnets and phosphate dosing and sacrificial anodes and lots of different methods for conditioning water. Many of which I think weren't working as well as people could reasonably demand them to. And so people went, no, I don't want a conditioner. I want a water softener, as to make sure I get the job done properly. And so conditioners got quite a bad name for themselves. And I think it's only been in recent years that you've seen us and a number of our close competitors and so on actually bringing some really quality results back into the market. And now we've got to shift that perception back again to say it's okay. There are things in the market which can treat the problem, do it really simply, because we take a very different approach. We say, no, we're not taking all those minerals out. They're really healthy for you. They're really good. All we need to do is temporarily just tweak that one mineral that causes limescale. We just need to temporarily change the way it behaves whilst it's traveling through your system, whether that be home or business, whatever. And so whether you use electrical magnets, sacrificial anode, we use an alloy, what you do is you just temporarily change the structure of the calcium carbonate from calcite into aragonite, both natural forms. And the aragonite form simply cannot bond. It can't do that sticking and that bonding, which is what causes the buildup of limescale. So it just flows through the system and disappears. So the conditioners can do a much simpler task, which is why they're much smaller. It's why, you know, in our case, we last a lot longer. We're trying to do a lot less of the water. We tamper a lot less with the water because we're not trying to take everything out. We're just tweaking it just enough while it's traveling through your system to not cause the limescale, to not bond. And then when it disappears down into the waterways, of course, it reverts back to, as everything will in chemistry, it reverts back to its normal form of calcite. But we don't mind then because it's a natural form and it's back in the waterways as it should be. So yes, there are simpler and more complex ways of dealing with it. And I think we're on a mission to sort of say, look, this is quite a big problem. It's really quite a big problem, but actually there is a really simple solution. We're not the only ones. We're not the only ones. We think we're the best. And you know, but there are a number of solutions that you can have which are, you know, light touch, easy to install, quick. And when you and I are talking about, you know, retrofit and making an impact on, you know, and getting things changing quickly, saving energy, I think that's critical because the whole insulation piece is such a big thing for people to do. And yet this is such a small thing and easy, you know, it's an hour to fit one of these, an hour to fit.
The questions are bumbling around in my head.
Yeah.
Firstly, you say we temper with the water. And earlier on in the conversation, you said that the dosing mechanism will be only on the heating system, not on the drinking system. Does your product sit on all of the systems so we can, once you've tampered with it, we can still drink it?
Yes, we tamper as little as possible.
Yeah.
So our system and other similar to us, but our system in particular will go ideally straight after the stop tap. So you go
right,
things in, stop tap, us, everything else. And then there's that confidence that everything else is treated. But because we're only converting it from one natural form to another natural form, you can drink aragonite. There's no reason why you wouldn't. It's just CO3 restructured. You can drink from every tap. You don't need the separate plumbing, and you're not having all of this paraphernalia. Yeah,
and we're not all going to start growing another head as such.
No, you'll be pleased to know, sir, that we are fully certified for safe drinking water.
It's a healthier, because originally dosing it, we're going to take all the good stuff out of the water, but we're not going to do that with your product, are we? We're going to keep the water to the best of its capabilities.
Yeah, and I think that's what we're seeing with quite a lot of our clients is actually they don't want all the hassle of looking after a salt softener. They are becoming more conscious of not having a negative effect on the environment, and they're getting that health discussion. They want those minerals. They understand that's good for your brain and your body and so on. And so, people appreciate simple when it can do the job. And now simple can do the job, whereas perhaps in the past it couldn't.
And then my next question, can your system reverse what we've got already?
Oh, yes, sir. It certainly can.
Which is very interesting.
Yeah. So particularly, it's lovely, actually, from a retrofit position. It's really nice to know that we can not only prevent the new limescale forming, but we can actually, I mean, it's not overnight. It does take a process of weeks and months. But what's fabulous is that as that aragonite, as it were, water's going through, it's slowly dissolving away that build-up of limescale. So we can't get systems back to like new, but we can get them back into much better order. So inside the boilers, inside, thermostatic showers, how many of those get thrown away because they start playing up and it's just limescale? Inside the system, the bit you can't see, we can strip out most, not all, but most of that limescale and get it back into good order, which again, extending the life of the systems, making them work more efficiently. So as a retrofit product, it's super. We're quite benign about, we don't care. You could be a new build, you can be a retrofit. We'll do the job just as well.
I've seen this technology, and it comes in all sorts of sizes. So presumably, we could take it from a house right up to a commercial, industrial type organization very easily.
So interesting, we were chatting about being a future build, and a couple of the conversations we had there were around agriculture and irrigation. And so we've got, yes, the little baby one for the domestic household, all the way up through, we talked a number of hotels, next size up, a few sizes up. And then the conversation with the agriculture is around irrigation systems and properly large scale inline units that will treat hundreds of litres a minute when they're irrigating in, well, these ones were for Africa, near Kilimanjaro. There are other discussions, Middle East and so forth. So yes, you're right, we have the full range, but the principle is identical, and the simplicity and the robustness, and I think particularly longevity, is certainly something I think appeals to our clients, because once it's installed, unless you physically unplumb it, it can't stop working. It just sits in the pipework and just does it, and you don't need to do anything. And I think
the life cycle of it.
So the domestic unit comes with a 30-year warranty on its manufacture, which we think is pretty good for most products.
Yeah.
But actually, we've got them going in industry now just up to 40 years, and that's in manufacturing where it's working 24/7 in water that is recycled and so on. It's not great quality. We've got them in mining where it's using really awful mineral-rich water, and they're still going at 40 years. So we put a 30-year warranty on the domestic ones, and a 10-year warranty on the commercial ones, just because anything longer doesn't really make a lot of sense commercially. But they're doing 40 years now with no sign of stopping. So when we're particularly, I find that fascinating when we're looking at things like the 2050 targets, the 2030 targets, the 2050 targets. And I have that peace of mind of knowing that, our product, if it's installed now, is still going to be delivering the same level of energy saving and carbon saving when we hit those really important dates as it is today. And nobody will have had to have done anything, just left it alone, and that's a very nice place to be.
Samantha, can we get hold of, or can the audience find case studies of what you've done before?
Yes, we're not very good at getting them because we tend to beetle around doing other things, but yes, we do. And we're getting better at putting them up on our website. So our commercial website has a number there which are commercial, and we're just starting to put up, we've got a lot of testimonials which we've kind of treated as being domestic case studies, but that's not quite the same thing. So they can find testimonials. We're starting to load up our case studies, which are domestic ones, because we're just getting better at that internally. But they can always ask us. We can always ask us.
And where do you have a website that you would like to promote now?
I'd love to tell you where my website is.
This is the new Google section. I've just created it, by the way.
Oh, right, great. So our website is www.halcyanwater.com, which is HALCYAN water.com, just for those who want to question the spelling.
Excellent. So thank you for giving that to us. Now, it's come to that time. I know you've been listening to loads of my episodes, not all of them because you keep getting interrupted, apparently. However, this is the time of the podcast where I like to see whether we can give something back to our audience today. And I know you have done throughout today, but is there something specific that you'd like to give back as a takeaway to our audience today?
I think for the audience that are commercially minded in particular, we can give back data. We have access now. We have done, well, we haven't because we're not good at it, but we've paid people who know how to do it, carbon figures, energy saving figures for a range of domestic buildings, for a range of domestic dwelling situations, for commercial settings. And so we want to bring those facts, those figures, which nobody else is doing, to the marketplace and say, look, this can help you specify. We can help you to demonstrate this carbon saving to your clients and so on. So that from a commercial point of view. And I think for our domestic customers, it's really it's more an education piece from us. It's just us being better at telling people so that they can save money. Bottom line, people need to save money right now. So we need to get it out there and say, this isn't complicated. we can help. Just ask us, we'll walk you through. If we're not the right solution, we'll also tell you that. We're very straightforward. So we have a lot of information on our website that we hope helps our domestic customers to unpick our marketplace, because it's a bit of a murky old place. And we see our role as a little bit leading the way, perhaps, in helping our customers to make the right choice. We are often that choice, but not always. And so we recognize that.
I think for me today is the understanding that the difference between soft and hard water is really a massive impact on what I've learned today, really. And the fact that, the hard water does start to degrade our heating systems. And I've always seen, the calcium building up on heating elements, even in my house, let alone on site. But knowing that we can stop that more effectively and reverse it even more effectively, I think that's something very powerful that we need to address. And I think it just water gets overlooked, full stop, doesn't it? That's why I really insist, energy management, gas, electric and water, it's a must, really key.
I'm really pleased that you do that, because it does feel a little bit like sometimes we're shouting into the wilderness. So it's, we have a grotty little subject that nobody wants to talk about.
Yeah.
And we're in a bit of the market, the water energy nexus, which, again, nobody's really talking about. So
we've been talking recently about a water quality issue, which hasn't really been on my radar, but it's become on my, and then we met and then we've been talking even more about it, and I've got a better understanding. And this is why I wanted you on here today, is to give that understanding to the marketplace regarding consultants. Now, a short story, I presented, so I do a lot of presenting in Africa and India, and I teach people how to do an energy assessment, and I showed them dripping taps and leaks and things like that. I couldn't believe the response they were giving. They were shocked, because water to them is so precious. It's really, and that reinforced where I was going with my gas, electric and water, because I've seen it around the world and I know how important water actually is.
Okay, no, I think that's really interesting. We do have a very limited view, I think, from our own place, and it's fascinating to see how other people view it. So yeah, no, I'm delighted that you have water in your mix. I think it's well overdue that we start talking about it. So it's great to have a platform to share it a little bit more widely. Thank you.
And we're going to invite you along to our Umlink platform, where we need to share water more on there. I like the fact that we're going to share water. That seems quite funny, doesn't it? We're going to give water away. So Samantha, look, I'd like to say thank you very much for coming along. And I would also like to say, you and your family, please stay safe in these times.
Thank you, Paul. It's been a real pleasure. So thanks ever so much. We'll see you soon.
Brilliant. Thank you very much.